New unicorn idea, next billion-dollar business. What if we just bought back MySpace? Because like a lot of you, I feel like social media's gone a bit wrong lately, so I figured we'd just make a newer 2020 free edition. So, of course, I developed it using React and TypeScript, because I don't really understand HTML and I never want to see a line of CSS. So I make a profile component, has your date of birth on it, your favorite band, personal hero, which song really represents me. And if you click on the Show Friends button, oh, I haven't got any friends yet. But if we pick to someone who's actually popular, and click on his friends, you see he has lots of friends. And this project, I'm actually going to do test automation. And I'm not going to give up when it breaks. I'm like really sure this time, I'm going to make it work. But then I'm sort of remembered why I give up every time. In what I like to call the top 5 reasons you give up on test automation. Number 1, having to rewrite the unit tests from scratch every time I change my code. I change how a component works, most of the tests won't pass anymore and often aren't relevant or need significant modifications. 2, they're flaky and they break easily. Sometimes I get desperate with tests and just start removing white space or whatever else I can find. Number 3 is they're tedious to write. You always copy and paste a bit in software development, but when I write tests, it feels like all I'm doing is copy and pasting and changing one line of code each time. And finally, or number 4, tests are often written wrong. Then you sort of get to the 5th reason, where you think, why am I even bothering with this? I could spend this time writing features. Now, I think the 5th reason is really an element of the first 4 reasons. Because we don't ask ourselves, why are we bothering with CI/CD? Why are we bothering with version control? We know those things add value. But the reason I think we get sick with testing is it's really frustrating. So whenever I find a problem like this, I always wonder, am I the problem? Maybe I just don't know how to test properly. So whenever I hit a fault like that, I go look at open source code. Because after all, what is the point of open source if we never actually look at the source? And what I found was a lot of open source projects, even very large ones and very popular ones, also don't bother with testing. They assumedly do it manually. So after looking for a while, I eventually found one that does do testing, and that was WordPress's Calypso new React frontend. Now, if you've ever read a unit testing book, then you'll be aware of the AAA of unit testing. Arrange, act, assert. Arrange means arrange your data. Act means do whatever action that you need to run your test. For this sense, render a component. Jetpack signup does sound very fun. And then assert means check that what you thought happened actually happened. In this case, they're using the React test library, where it checks if the expected test is both visible and has the correct CSS class. Now, at this point, I'm like, when you add a new test case, you copy and paste that again. And I don't think that's very maintainable code. If I wrote code like that in my normal code base, where instead of defining reusable functions, instead of defining good abstractions, I'd get roasted in code review. But if I don't include code like this, I'll get roasted in code review. So at this point, I was like, well, I guess my tests aren't bad. We're clearly doing it wrong. And whenever I face like a design question like this, where I'm trying to find a new way of doing this, I go back, I ask myself, why are my tests hard to maintain? Because fundamentally why tests break is code can't be robust to code changes. Doesn't matter how many try catches you put in, there's no error handling that can help. However, it can be easier to change. Which means I go back to my software-defined principles, which, as you can tell by the title of this talk, are the solid principles. Starting with the silent D of the solid principles, don't repeat yourself. Don't repeat yourself states that if you find yourself doing the same code over and over again, defining the same variables over and over again, define them in a single location. Going back to an actual test case for the component at the start, I can immediately move the arrange out of the test, leaving the act and the assert inside the test. But you notice I'm now repeating the act. So I can define that as a separate variable. All of a sudden, if I need to change my render or if I need to change the data, it's one location. I can go a step further. Because it's TypeScript, I can just do a for loop and loop over a whole list of indicative examples of people and run the test for each of those people, and I have a whole list of tests broken down by each edge case. If I need to add another person, maybe I found a bug where if you have a Spanish name, it's not represented, it's an error, I just add another person. Going a step further. Next, for that conditional logic I had at the start, where if you have friends, it renders a list, otherwise it doesn't, I can just filter the list with an if statement. If they have friends, check that each friend is in the list. If they don't, make sure the sad message shows so they engage with our platform more. Finally, you can take this a step further when you realize that you don't need to redefine the test data for each test. You can move the test data into a separate location and then reuse that same data across your entire code base. Which means that, again, if you find an edge case, you add it once, test everywhere. So with just using dry alone, changes in data is now easy. It is easy to add new test cases, and there is consistent test data across all of my tests. I'm like, well done. I reinvented parameterized testing. Let's take it a step further. Moving on to the S in the solid principles, single responsibility principle. Single responsibility principle states that each entity should have exactly one responsibility and do it well. For example, in a professional kitchen, they have a separate station for each of their chefs. You have the pasta chef, the fish chef, the meat chef, and based on my knowledge of professional kitchens, which I learned entirely from Kitchen Nightmares, you have to have a dedicated yeller. So, looking again, I identified 4 responsibilities. We have the assemble, assert, act, we saw before, where assemble provides the data for a certain act, and then you have a 4th one, combine. Combine is responsible for combining the various modules of assemble, assert, and act into a unique test. And this is what I really wanted to go for, a modular approach, because I wanted to be able to easily combine different data with different actions with different assertions. Now, at this point, I'm going to speed up our traversal of the solid principles. Because when you're designing, you don't just apply one principle at a time, unless you're writing a tutorial. So we're going to have to do a bit up front. Moving on to the O, the open-close principle. Open-close principle means something is open to extension without modifying the code itself. Now, a good example of this is Kirby. Kirby can absorb the powers of his enemies. Super impressive. And there are defined ways that he does it with each one. But Kirby doesn't become a different person. Now, a typical way we'd see this in code is code you can pass in, say, an object with a database interface, which deals with the operations of the database. Or you pass in a function that's a callback when you render the component, and so forth. Moving on to the I, interface segregation principle. Now, this one's a bit of a relic of the past, because back when we had C++ and Java, creating new types was a whole ceremony. You had to create, sometimes you have to create 3 files to do one thing. You define the interface, you define object to take the interface, and you define object to receive the interface. And what this wanted to prevent is often when you have that much code to define a type, you'd end up with interfaces that are overly broad. The interface segregation principle means that objects should only implement the methods they actually use. To prevent situations where you need an interface with 1 method on it, and has 10 methods on it, and you have the actually implemented method, and then 10 methods that throw a not implemented exception. In TypeScript, and in modern day programming, what that looks like to me is when you define interfaces, you should think about what should be defaulted out, what is really necessary, and what isn't necessary. Moving on to the D, the dependency inversion principle. Now, some of you might know this as dependency injection. The idea here is that rather than having the code related to the dependency inside the function itself, you should pass it in. The typical example given here is when connecting to a database, the object that writes the data shouldn't be responsible for the connection. The connection should be passed into it. Or you could go a step further and define an interface for writing data to any database and then pass that interface into the object. In our particular example, it means that we pass in the render, we pass in the assert, and we pass in the assemble. In addition to this, I have my own little preferences for code. First of all, I'm a big believer in operations over data versus explicit written code, meaning that I like lists of functions that I map over, which leads to the second point of I see behavior as data, meaning that I'd see a list of functions as relevant data as a list of people. Now, that doesn't make much sense until I show you this code example. So a normal sane developer would do the top approach. So they need to validate a person. They do a number of if statements. If all the if statements are true, you return true. So I do it the second way, and I create a list of free functions which all make those checks, and then check if every single one matches. And the reason I like doing this is now I can easily add additional validators and combine different lists of validators. And the reason I bring this up is it's going to be very relevant to all the code examples. So that brings me to my first pattern, the create, activate, assert pattern. And what I found was just about every test I need to write for the UI, and more broadly speaking, any other interactive system, revolves around setting up the environment, i.e. rendering the component, zero to many activators, and then assert that what I think is true is actually true. The activator is a slightly complicated part. So the reason why I say zero is a lot of the time with React, you just want to check that what the component rendered correctly. You don't really care about interaction. However, sometimes you need some user clicks. Sometimes there's a complicated set of user interactions that you're trying to test. That's why you have 0 to n activators, and what they look like in actual code is passed in functions that could do any number of actions. So going to this code, this is the backbone of the entire approach I came up with. So at the top we have a simple type. The query name is the test name, and the screen query is the assert part. So when I said expect this to be on text, it just runs that. Now you might notice a rather ugly peak TypeScript type definition on there. And if you've been on Twitter in the last few weeks, you know that someone posted something spicy on GitHub and then everyone debated about it for a week, which is that sometimes in TypeScript it can feel like wrangly types. The reason why I have that ugly bit of TypeScript there is just basically like, if I define a lambda, I don't care what it returns, just ignore it. So onto the main part of code, which is the pattern. It's just as I said before. It sets up user events because I'm using the React test library. You have to set up user events to simulate user interaction. And then renders the page, and then passes in the user object to the activator, so it can do the user interaction, and then tests the query. The last little bit is a wrapper around that. I'll get to why later, but that's to make sure I can test it. Because something I found out during all of this, and it probably should have been obvious in hindsight, is you can't define a test inside of a test. That wouldn't really make much sense, and just really doesn't like it when you try. So right now, it looks like an overly top abstraction that doesn't really provide much value. But what it allows is standardized testing. Let's look at an example. So starting with something really simple, I can combine all of the tests I have before into a list and then map or iterate over a list. So for those who aren't really into the functional stuff, map is just a fancy way of doing a for loop in one line to show off to your friends. That's pretty cool, but I can do better. Next month for the friend list, because it's all just data now, I can put in each friend in a person into a test case generator. I have only one test case there for brevity, but I could have any number of test cases. So I just have them detecting the name, but I could have test cases for making sure it has the right href, making sure the image is present, and so forth. Then I simply map over all those test cases, and now I've tested each friend. Going a little further, what I realized is that there are some discrete categories of tests. And now that I started treating my tests like real code, I can create reusable functions that then standardizes those behaviors across the entire code base. Stuff like text being absent, making sure the right HTML attribute is on the right HTML, making sure that specific HTML is in the test, which is a bit fragile but sometimes necessary, and snapshot testing. The benefit of this is when I want to change the behavior of any of those tests, for example, if your test harness becomes deprecated, thanks Airbnb, then you can change it all in one location. Going a little further. Next, I realize is now that test cases are just data, some test cases might be universal across your entire app. So for example, the loading behavior of your app might be the same regardless of what screen they're on. So you can start defining what that looks like, and then all you need to do is find a renderer that keeps the app in a loading state. Same with error. You can have it error out using some preconfined condition, and then have the same error behavior across the entire app. And if you need to change that behavior, you can do it in one location. Going a little further. This breaks a little bit from our MySpace example into actual production code. Something I like is my loading or error indicator. Depending on the props, it will either show loading or error. By combining the screen test case with the props, I can now define them all in a list and map over them and just pass the props into the renderer. Some other examples, which are a bit too verbose for a slide. My favorite one is cross-site scripting, the most annoying attack to deal with, because if you make one mistake, some hacker will eventually figure it out and make a self-retweeting tweet. Now, cross-site scripting is when some user passes in some data that, say, executes JavaScript and then retweets itself. Now, the way you fix this is you purify the input of the user. What I do is, for every relevant field, I pump that field, I put in the each example of bad text, pump that through a purifier, and then make sure it meets the purified text. So if the text should be purified, it should look like, go from this to this, and use those same examples across the entire code base. Next is accessibility tagging. If you have common standards for accessibility tagging across your code base for certain components, one set of test cases works everywhere. One thing I used to find very tedious is routing. The number of times I have to create a memory router to test that my page redirects to the correct page gets really tedious. But with a little bit of a test harness, you can have one router set up for each of those cases, and then you just pass in a render function and the URL it's supposed to re-render to. 1 second. Finally, if you have a legal department, you might be used to the idea of having to have the certain footer on every page. With this approach, again, you can just make a list of test examples that have to pass every time. Moving on to other patterns. So for these two, I like to call them climbing the pyramid. So for those who aren't aware, maybe you're a little too young and we've sort of moved on from it, the testing pyramid has the unit tests at the bottom. They test discrete functions. Then you move up to your service/integration tests, which test that your code can integrate with various external services. And then right at the top, you have your UI/end-to-end tests. Typically speaking, what we did is we'd have 3 separate code bases. We'd have all of our unit tests, and then copy, paste, and change dependencies, all of our integration tests, and then do it again for UI tests. What I found is the first pattern to sort of do this in an automatic fashion is dependency unwrapping. So when we do unit tests, often we have to mock out our external dependencies, like our APIs. Now, the benefit of this is the API acts in a consistent way. You don't necessarily need your API spun out the whole time, and you can test, does the code work, or is it the dependency that's the problem? The downside to this is if your assumption about how it works is wrong, then your test pass, but your code fails. What you can do using this approach is you can loop over all your test cases, moving one dependency at a time to figure out where exactly your code breaks. Is it the web API? Is it the database? Is it the core logic of your app? And this allows you to know exactly where your code is broken before you even open your debugger. Tools reversal. Another way we climb the testing pyramid is we change our tools. So if I want to do the unit testing, I would use a React testing library. but for end-to-end testing, I'd use something like Puppeteer. With the correct abstractions, you can take the same logic and then move up the hierarchy to do the unit level testing and then test the different browsers. Moving away from the testing pyramid, I like to structure my backends as pipelines. This is a really obvious one, but I see lots of examples of people not using it, where you create a single test data import to test the first segment, you pump it to that, and then for the second segment, you pump it through the first segment into the second segment, so that when your pipeline's being tested, you only need to define your test data once, and then each segment's output becomes the input of the next segment. So again, you know exactly where your pipeline failed. And finally, condition/assumption testing. So UI apps these days usually have tons and tons and tons of settings, which we just don't bother testing, which is where you get those edge cases like, I'm in dark mode, I increased my zoom to 500%, and I turned off half the settings, and why my app doesn't work? With this approach, tests are just data. You iterate over the different settings and configurations, and then you can test which configurations break your tests. You can also run with different browsers and browser configurations, though that should probably be done outside TypeScript in something like a CI/CD platform. So I'm a big believer that in software there are no clear wins. Everything is a trade-off. But I also like to start with positive. So the benefits is it's easy to add new test cases, allowing for fine-grained testing, which I covered in the patterns. Repeated logic isn't really an issue anymore. It's much reduced, much less copying and pasting. Standardized testing is what I find when it comes to tests is, depending on which developer writes them, they're usually dramatically different, absent, or dramatically different in quality. Once you have some clear categorization, you now have a standardized test suite. So if I go to any developer's tests, they should be using those categories. I can just sort of browse through what they're testing. And once your tests are data, you can manipulate, transform them, iterate over them, whatever you want, combine them, and so forth. Consequences. The first one made me laugh when I realized your tests now need tests. Because if you're defining common functionality and standardized testing forms, you really should write some tests for those. This is annoying because writing tests for your tests feels really silly. And some things you can't test, like that fact that I need to write a wrapper for that. But the benefit of this is, one of the issues with tests is sometimes the tests are wrong. If I know that my standardized categorized tests are correct in their behavior, that's less of a concern because I'm not redefining the wheel every single time. The second one is something that usually comes up with, developers who are more old school, where they like their code to be glanceable. Now, that is a legitimate concern because you're creating all these abstractions. Can I still read my code like a book? My sort of response to that is, these days, if I make a web API request, I'm going to be like, hang on, where's the TCP/IP packet logic? Where are the headers passed? No, I sort of have those abstractions in my head. If I brought someone new into this code base, they'll be like, what the hell are these tests? These aren't any tests I've looked like. What do I do? But once you understand the abstractions like everything, I think it becomes fairly reasonable. Before we wrap up, I'd like to take a moment to thank our sponsors. Now, in addition to helping with the giveaway and all that, they make this event possible. I don't get the chance to talk in front of developers too often, and this is something I've been working on for a number of years, and I'm really happy that they can give the opportunity. I'm also really happy they can keep the ticket price so low, because it makes it more accessible to more people. So overall, I call this approach data-driven testing, because everything has to be driven by something. But this might not be the best way of doing it. This is my interpretation of how to make my testing code better. Because the whole thesis of this talk isn't do it my way, it's how can we make it better? Because I don't think the way our tests are currently written are very maintainable. I think that's why we give up on it. And as developers, we've proven that we're willing to spend tons of time on non-feature stuff. So I suppose the call to action here is, what would happen if you wrote tests that are worthy of being maintained? What would happen if you applied your software craftsmanship to them? Because I'm not the best developer in the world. Hell, I'm probably not even the best developer in this room. Actually, I'm definitely not. I can see multiple people who are better developers than me. But that's sort of what I'm getting at here. So we've got a few minutes for questions. The only sort of self-promo thing I'll do is I should be on social media because I want to do more events like this. In a very autistic way, I knew I should be on social media, so I spent the last year reading Twitter. It's been a wild year on Twitter, by the way. If you are a Twitter person, feel free to give me a follow. I would appreciate it. Posts are coming in like 2024 probably, whenever I feel I've done my analysis. We've got a few minutes left, I think. So if anyone has any questions, now would be the time.
Yo, dog. Hey, so I think this is an interesting perspective. I worry about the fact that, like, obviously you're quite a talented developer putting together these like abstractions, but what happens when you leave, a new dev comes in and has to like very quickly upskill on, I guess, your domain-specific like meta language to testing? Because I've seen instances where people have done some sort of abstraction on top of tests, but then they've left, the next person hasn't really maintained them. So now there's like 5 or 6 different ways people are writing tests. They all work, but they're not consistent with each other because there's no like uniformed like structure to like how we should all be doing it. So I guess I'm curious your thoughts about that.
I would consider that more of a team culture problem. We deal with abstractions every day, and learning a new abstraction is always annoying. Like everyone remembers the first time they had to learn the cloud, and then suddenly we're multi-cloud, and now we have to be on Azure. But if you make an abstraction like this in your team, ideally one day use one that's open source. You should have documentation around it. You should have coding practices around it. Whoever onboards the person should be like, this is how we write tests. And if you have a situation where you end up with like sedimentary layers of tests, then that's probably a problem with your team's culture around coding in general. Because if that's in your testing code, I'd imagine it's in your main code base as well. However, I have been in a situation where someone wrote something that's overly complex with like many layers of abstraction, clearly just trying to show off that they can do a sick 720 while coding. That's why I like to keep things simple with a data-oriented approach. You always have to be careful with abstractions though.
Cheers, mate.
Hello. I'm a developer. Sometimes I do the test first. I write the test first, and then I write the code. Or sometimes I write the code and then write the test. Which one do you think is the best?
So what you're getting at is a lot of people feel that you should write your test first, and then that defines how your code will function. I'm not a TDD person because I just found that my brain just can't work that way. I think in theory, if your brain works that way, writing the test first makes more sense because then you don't have biases when you write your tests and you have the clear defined of what the inputs and outputs should be. But I don't think it's enough of a win to try and rewire how my brain works.
Thank you very much.
You mentioned before having pipelines and making a progression from your unit tests to your UI integration tests. How do you manage not repeating your data prep between your unit tests and your integration tests?
Right. It really depends. So with the dependency unwrapping, that's relatively easy to do because you just have the same test, but you just pass in different mocks each time. For integrating with stuff like Puppeteer, going from React testing to Puppeteer, that's more of an idea I have. I haven't quite implemented it yet. But basically, I found that there's a lot of common steps. So you just have to find the right sort of abstraction in converting the user interaction in screen testing to the user interaction Puppeteer. The data itself is the easier part because you would you'd use, the way I do it is, for my dev version of the app, I have a dev data directory. So instead of reading from the cloud, I have it in a directory using a little bit of dependency inversion. And that's how I do it. And then I try to keep that dev data consistent with the test data. I'm not sure if that answered your question.
No, that's great. Yeah, mocking approach to proxies for data APIs. Great.
I believe, oh, one more? Okay.
Sorry. I think you were saying something about starting with like everything mocked in your test, and then trying to remove the dependencies when you were like trying to track down issues. I guess I was hoping to hear more about what that means.
Yeah, I think an example might help. So let's say I have a function that grabs some data from a web API, grabs some data from another web API, and then writes it to a database. Now, let's say there's some transformation there. Let's say it capitalizes all the text. So what that would look like with maximum mocks is I mock out each of those requests by mocking out the getter function on my HTTP client. I then, so those are the two ones. I mock out the database by mocking out the database write function. So it writes to nothing and just returns a success automatically. So those are my three mocks. The test would be testing that each of the fields are capitalized. So the first iteration of the test would just test that the capitalization works correctly. The second one removes the first mock and then tests that the code still doesn't crash and you still get the correct return from the database. So let's say we remove the mock from one of the web APIs, check that they would check that the data we expected to get using the mock is the same as what we actually got. Same for the second web API's mock being removed. The database one will check that, are we actually writing data to the database in the way it expects? For example, is the SQL structure the way we expect it to be, etc. And check that it still gives the success. So with the same logic, same test data or ideally, or similar test data, but we just check at each stage that each of the mocks being removed doesn't break the test.
So you mean, when you say remove a mock, you mean make a real call?
Yes.
Okay.
Cool.
I believe we have time for one more question.
One more, cool.
I wanted to ask you about your comments about your code becoming less glanceable when you're adding abstractions. I've always thought that adding an abstraction over something much more complex can make your code more glanceable. It makes it easier to understand what's going on because it moves some of that complexity away. Can you have examples where you're writing tests to make something that's more complicated easier to understand?
Yeah, I actually completely agree with you. Otherwise, I wouldn't have made this approach. When I think about criticisms or consequences of an approach, I usually think about what other people with different experiences and different biases in their software development would think. And I have encountered developers who really like simplicity, really like knowing what's going on under the hood, sometimes even to the extreme. And I was just trying to deal with that particular criticism. But abstraction can get complicated if you ever, because I learnt Haskell a long time ago, and that is maximum abstraction. And where it gets complicated is when you have a bunch of functions where it's not clear what they do and what their intention is, and a bunch of really complicated abstractions where you're like creating 6 different objects and that somehow achieves your goal. But mostly I was trying to address people who sort of think about code in a different way. Thank you very much for your time this morning. I'll be hanging around for a little while longer if you want to question me off stage.